All right, these are the answers to the last 2 pages of our quiz 3334 review. So for this one, we're going to take the derivative, which is 2 plus derivative sign is cosine, leave the 2x alone, then times 2. I'm going to set that equal to 0. In doing so, I'm going to go ahead and pull a 2 out. And I can divide by that 2. And so I'm really looking at when does 1 plus cosine 2x equal 0, and that's when cosine equal 2x equals negative 1. So now what I say is, well, then when does cosine equal negative 1? And if I think about unit circle or even just the cosine graph, I know that it equals negative 1 at pi. So the cosine of pi would be negative 1. That means 2x has to equal pi, which means x is going to be pi over 2. That's our critical point. So now if I put pi over 2 down, I'm going to test my derivative for things less than pi over 2. So let me put in, say, put in 0. The cosine of 0 is 1. 1 times 2 is 2 plus 2. That gives me a positive value. So I know that my function is increasing there. All right. And then if I pick something after pi over 2, say pi, I've put it in, the cosine of 2 pi is also 1. So that's also going to give me a positive value, which means my function is still increasing. All right, so at that pi over 2, I don't have a change in the derivative there. All right. And so my relative extrema, I don't really have any. There are none, because I didn't change in my thing there. All right, now as far as the second derivative goes, derivative 2 is 0. Derivative cosine is negative. Sine, leave the 2x alone, times 2, which is going to multiply the 2 that was already there, so it'll really be 4. So I'm going to get a negative 4 sine 2x. All right, and when I set that equal to 0, I'm really looking for when does sine 2x equal 0. And I know that sine equals 0 at 0 and at pi and at 2 pi and at 3 pi. And so if I set 2x equal to all of those, I'm going to get 0, pi over 2, pi, 3 pi over 2, and then that's, I think, my thing. So I'm getting lots of possible points of flex points. If I were to put, basically all of them, I don't really need to put 0 because that's at the beginning. But if I put pi over 2 and pi and 3 pi over 2, all right, and then 2 pi, like I said, is at the end here. If I would say, put pi over 4 into the second derivative, I would get sine of pi over 2, which is 1. It's a negative, though, so I'd get a negative here, which means we're concave down at that point. If I put, say, 3 pi over, or pi, 3 pi over 4 in, I would get sine of 3 pi over 2, which is positive. And so, again, that would give me a concave down at that point. If I were to put, say, 5 pi over 4 in, though, then I would get 5 pi over 2, which would then give me a positive value here, which would make this concave up. If I put something in big here, I'm also going to get a concave up. All right. So my intervals of concavity from 0 to pi were concave down. From pi to 2 pi were concave up. And so we had a point of inflection at x equal pi. All right. So there's a lot going on in this graph. It just doesn't look like it from what we answered there. All right, then our last one. We are given a graph here of f of x, and we're asked to fill in this table based on whether at these points we have a positive, negative, or 0 at them. So for f of x, it's just a matter of are we above or below the x-axis. So a, b, and c are all above, so a, b, and c will all be positive. D and e are below, they'll be negative. For the derivative, it's really a question of are you increasing or are you decreasing at those points. So at a and b we're increasing, those will be positive. C and D are decreasing, those will be negative. E is increasing, that'll be a positive. And then for the second derivative, it's a question of are you concave up or concave down at that spot. Now a is on a line, so its second derivative will be 0. B is on this curve, and it's concave up, so that's a positive second derivative. C is on the concave down part, so that'll be negative. D and E appear to be on the concave up part of this, so they'll both be positive second derivatives. And then here we have a second derivative, or a first derivative graph for this here, and we're asked when is f of x decreasing? We'll be decreasing when our derivative is negative, and this derivative is negative from 2 to 4 and 4 to 6. Or if you want to say 2 to 6, the AP will accept either of those. Okay. Where's the relative maximum for f of x? So I'll have a relative maximum when my derivative switches from positive to negative. Okay, and that switch from positive to negative happened at x equal 2. Where is f of x concave up? F of x is going to be concave up when its derivative is increasing, because that's when the second derivative is positive. This is the first derivative. It's increasing from 0 to 1, from 3 to 4, and from 5 to, we'll say, infinity. They didn't give us an endpoint there. Okay, and then where are the points of inflection? The point of inflection is going to be when our first derivative switches from increasing to decreasing, or decreasing to increasing. So that's where we're going to have a point of inflection here. So that switch occurred at 1, at 3, at 4, and at 5. We'll have 4 points of inflection there. Those are the places where the first derivative switched from increasing to decreasing, or decreasing to increasing.